The XGB PLC offers many ways to communicate over Ethernet. The onboard Ethernet port is referred to as the internal FENet and allows Modbus TCP and XGT protocols. For the Modbus TCP, the PLC allows configuration as both a Modbus slave and master. In LS documentation, Modbus slave is also called Modbus server, and Modbus master is also called Modbus client. The Modbus server and client functions for the XGB PLC can share up to 16 concurrent connections. Let's set up the XGB PLC as a Modbus server. The first step is to set the TCP IP settings. To do this, we will go to the project window on the left side of the screen and double-click on Internal FENet. This will open the Standard Settings FENet pop-up window. Here we can set our IP address, subnet mask, gateway, and DNS server if needed. We can also use DHCP to allow a local DHCP server to automatically configure the IP settings for the PLC. Using DHCP can lead to potential network routing or unintentional IP address issues, so be careful when enabling this setting. Once we configure these settings, we are ready for the Modbus TCP configuration. If we are using the PLC as a Modbus server, we can go to the Server Mode dropdown and set it to Modbus Server. We also use the Number of Dedicated Connections field to set the number of connections that will be reserved for external Modbus clients with our PLC acting as the server. We will leave this at the default of 3. We can then click the Modbus Settings button, and the Modbus Settings window will open. In this window, we can configure the starting addresses that can be accessed for bit and word, read and write information from an external Modbus client. The bit read area address will be the internal memory location starting address that will be accessible from a Modbus function code 2 read input status. The bit write area address will be the internal memory location starting address that will be accessible from a Modbus function code 1 read coil status, code 5 for single coil, or code 15 for multiple coils. The word read area will be the internal memory location starting address that will be accessible from a Modbus function code 4 read input registers. The word write area will be the internal memory location starting address that will be accessible from a Modbus function code 3 read holding registers, code 6 preset single register, and code 16 preset multiple registers. Let's set our bit read area address to %mx0 and our bit write area address to %mx100. We will then set our word read area to %mw100 and our word write area to %mw200. The direct variables listed here will be accessible at the first Modbus offset address and will increment with each offset. For example, if we wanted to read %mx2 or %mw102, they would both be available to the Modbus client at the third offset address using the corresponding function code. We select OK, and then OK again to confirm the configuration change. We can then write this change to the PLC and go into monitor mode. We have a Do More BRX PLC configured as a Modbus client connected to our XGB PLC. Let's add %mx100 and %mw200 to our Monitor 2 window and display the data as an unsigned decimal. If we write the first Modbus coil in the BRX to true, we see %mx100 go true. If we write 1000 into the first Modbus register in the BRX, we see %mw200 show 1000. Changing the Modbus function code would allow us to read data from the XGB in those ranges, or the %mx0 and %mw100 ranges.